Okay, Trig, this is the second half of section 8.2, which we started doing inverse trig functions with. Lots of new information in section 8.2, so I apologize if that was a little bit confusing. Hopefully this section will clear some stuff up. We did sine and cosine in the last video. This section we're going to talk about tangent a little bit, but I got a new unit circle here, so mine's not all messy. But inverse sine and inverse cosine live. So inverse sine lives in the first and fourth quadrant. Inverse cosine lives in the first and second quadrant. Okay. When you're doing inverse sine, we talked about how inverse sine, his domain goes from negative pi over 2 to positive pi over 2. So they won't call this 3 pi over 2. They will call that negative pi over 2. They won't call this 5 pi over 3. They'll call it negative pi over 3. This guy will be negative pi over 4. And this one, they'll refer to it as negative pi over 6, okay? And that's only because like 11 pi over 6 on the graph of sine is all the way up here at the top, and that would be out of the domain, that sectioned off area. This 11 pi over 6 and any of those others would be too high up here and would not pass the vertical line test if we included them. So we have to find the equivalent of that that's within this section right here, okay? So that's kind of how we section him off, okay? For cosine, you don't have to do any of that because he just goes from 0 to pi, so 5 pi over 6 is totally legal. You don't have to change him at all or anything like that, okay? So that's just kind of how he works. Right now, example 4 is kind of a far-fetched, so bear with me here. But they want us to evaluate sine of inverse cosine of v, and write that as an expression. Okay, v is just a variable. V could be called x. Okay, and I'm going to write that as v over 1. Okay, so I'm going to kind of refer to my unit circle here, but we don't have a v on our unit circle. I just want to show you that we're going from inverse cosine and we're trying to evaluate sine. Okay, and those two things don't just cross each other out. Like inverse cosine doesn't cross out with sine. But what I'm going to have you look at is sine and cosine, the inverses of those. The one quadrant where inverse sine and inverse cosine agree with each other is in quadrant 1. Okay, so anytime they ask me to do something like this, where I'm going between sine and cosine, I'm going to draw a triangle in quadrant 1. The reason for that is because sine and cosine only exist together in agreement in quadrant 1. Otherwise, cosine also exists over here and sine exists down here. But the one quadrant that they share together is in quadrant 1. So what I'm going to do is I'm going to draw a little thing here, and I'm going to draw a triangle in quadrant 1, okay? And so if we just think about what this section inside of this parentheses means, like cosine, inverse cosine of v, and I wrote it as v over 1, and you'll see why here in just a second. What that means is that means cosine of some angle theta is going to be v over 1. Okay, that's where that comes from. And then to get the theta out of there, I would end up taking inverse cosine, and inverse cosine, and that's how they get inverse cosine of v over 1. Okay, so I'm saying some angle has the cosine of v over 1. Here's where angle theta is going to live. So some angle theta has a cosine of v over 1. Well, cosine means adjacent over hypotenuse. So of this angle right here, the adjacent side is going to be v, the hypotenuse side is going to be 1, okay? And then what I need to do is I need to figure out what this side is, okay? And how can you do that? Even though they're ugly things, like v and 1, you can still use the Pythagorean theorem to do that, okay? So I can do, 1 has to be my c squared, so I have c squared, let's go v squared plus question mark squared equals 1 squared. Okay, 1 squared is just going to be 1. V squared I'm just going to leave as v because I can't write it any different. But then I'm going to subtract that. Okay, I'm going to subtract v squared from both sides. Okay, so I have my question mark squared. This is really hard to do the Pythagorean theorem when you have such ugly things. Is going to be 1 minus v squared. Okay, that's what he would look like. And then I'm going to end up taking the square root of that. So my question mark, or that side, is going to be the square root, as ugly as this is, the square root of 1 minus v squared. How ugly, how ugly. That's what this side is. Okay, so I'm going to erase him. And I'm going to say this guy is the square root of 1 minus v squared. Okay, so now where are we at with our expression? This triangle I created from this information. So by this information, I know what this triangle looks like, right? And now I just want to find sine of that thing, right? I just want to find sine of this thing, sine of angle theta. So sine of angle theta here, living in the middle there, is just opposite over hypotenuse, which is just the square root of 1 minus v squared all over 1, or just the square root of 1 minus v squared. Okay, so that was terribly, terribly, terribly ugly, but we've written it as an expression for v. We're going to do that same kind of type of thing in example 6, but it's going to be a little bit less messy just because we actually have numbers to do. So keep that in mind that this is going to show up again. Okay, so inverse tangent function. We haven't done this one yet. Inverse tangent. Okay, so the regular tangent, if I draw what he looks like an x cubed function. And here's my vertical asymptotes, and then he repeats again all over there. What they've done is if we flip him, if we invert him and find his inverse, he's going to do one of, let me make sure I draw this right, he's going to do this, okay? He's going to do that, just like this thing says, okay? And instead of going from negative pi over 2 to positive pi over 2 here on the x-axis, he's going to do that on the y-axis. So negative pi over 2 to positive pi over 2, okay? And then they just went negative 10 to 10 because he will continue to go on forever this way and forever that way, okay? It's not from negative 1 to 1 like the other ones were, okay? So there's how that works, okay? So the domain is the set of all real numbers because he's going to go forever to the left and forever to the right. But the range, they're going to chunk him off and just do from negative pi over 2 to positive pi over 2. So that kind of looks familiar. If we go back to our unit circle, which two quadrants, if we're going negative pi over 2 to positive pi over 2, which two quadrants is inverse tangent going to live in? He is going to be the same as sine, okay? Inverse tangent's going to live here and there. That's where he's going to live, okay? And so he kind of has the same properties as what sine does. A while back we had even and odd functions, and I don't know if you guys remember this, but cosine was the only function that was an even function. Sine and tangent were both odd functions, so sine and tangent have a lot in common with each other. Cosine is kind of the odd one out, always. Okay, so sine and tangent are kind of consistent with each other. What I'm going to do is let's go down and let's evaluate. Let's see if we can figure out some of these for part A and part B. So they're just talking about in these boxes about how inverse tangent goes from negative pi over 2 to positive pi over 2, that type of thing. So evaluate in part A. They want us to evaluate inverse tangent of 1. So they're basically saying, where is tangent 1? So at what place is the value of tangent 1? Okay, so I can see that over here. Tangent is 1 here, and tangent is also 1 down here at 5 pi over 4. Okay, so at those two places, at pi over 4 and at 5 pi over 4. But which one of those am I going to use? I'm only going to use the pi over 4 because that's the one that's in the domain of inverse tangent. It has to be an angle that's in the first and fourth quadrant, and pi over 4 is the only one that does that. So this answer is going to just be pi over 4. Okay, let me go down. Pi over 4. Okay, now, this next one is saying inverse tangent of 136. Okay, on my unit circle, if I'm looking at tangents, I only have like square root of 3 over 3, or 1, or the square root of 3, or undefined, or any of those all the way around. Okay, I do not have a 136 on my unit circle. So what do? I am going to use my calculator. Okay, and what this is saying is that tangent of 136. Okay, this is saying evaluate and find where tangent is 136 at. So basically, if I think about that on the graph, 136, like this is where 10 is at, right? 136 would be like all the way over here. They want to know what this value is, like what y coordinate is 136 at, okay? Y36 is going to be way, 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 way out there, okay? And so we're going to evaluate this just using our calculators, okay? So we would just do inverse tangent of 136, okay? my calculator right now is in degrees. So I am getting, in degrees, 89.5, we'll do 89.6 degrees. Okay, 89.6 degrees. Okay, if I do that in radians, let's go radians, it will be 1.56 radians. Okay, all right, and now the magical thing that I want to explain to you that I didn't do in the last section when we used our, or in the last video when we used our calculator, is that even though 136 is all the way out here and is in like basically another realm almost, what will always happen with your calculator is your calculator will always revert back to giving you an answer so that it is in the domain of tangent, okay? So even though 136 is all the way to the right or whatever, it's going to reduce your answer all the way down, so it gives you an answer for inverse tangent that is in the first or fourth quadrant, okay? So if I think about 89.6 degrees, that's barely in the first quadrant, but it is. It's going to be like way up here, really close to 90 degrees. But your calculator takes that really, really large number and reduces it down so that we have it in the inverse tangent, or in the domain of the inverse tangent, okay? So I hope that kind of made a little bit of sense. I didn't say that on, let's see, on the last section when we did this, right? Inverse cosine of negative 0.63, okay? What it's going to do is your calculator is going to reflect an answer that is in the domain of inverse cosine. Now, inverse cosine goes from 0 all the way to pi, right? He does the first and second quadrants. So from 0 to 180 basically, and 129 is going to be in the second quadrant, which is in the realm of the inverse cosine of, it's in the second quadrant, so it's abiding by the rules. It's gonna, my calculator is always going to spit out something that's in agreement with where the domain lives, okay? All right, so last one, example 6, exact values. They want us to do cosine of inverse tangent of that thing, right? Okay, so I look at my unit circle, and I don't have any square root of 5s on my unit circle, but I'm only going to look at the unit circle because we're dealing with cosine and tangent. We're trying to go back and forth between those two. And the only quadrant, again, that cosine and tangent have in common with each other is that first quadrant, okay? So this is going to help me create a triangle that's in the first quadrant. Just a little FYI, whenever they give something to you like this, you're going to draw a triangle in the first quadrant. But that's why, is because sine, cosine, and tangent all are in agreement in the first quadrant. That's where inverse cosine lives always. There's nothing that lives in the third quadrant. He's just kind of hanging out. He's in a different place, okay? So inverse tangent of 5, the square root of 5 over 2. This means that if I have some angle called theta, that tangent of that angle theta is the square root of 5 over 2, right? Because to solve for theta, I would take the inverse tangent of both sides. So tangent of that theta is square root of 5 over 2, and that can help me label the sides here, okay? Kind of like, this is exactly like what we did in example 4, but this is going to make a little bit more sense because it's not v's and square roots of grossness, okay? So we have this going on here, and tangent is opposite adjacent, okay? So the opposite side is going to be the square root of 5, the adjacent side is going to be 2, and I need to find the hypotenuse, okay? So just use the Pythagorean theorem. I have 2 squared plus the square root of 5 squared equals c squared, okay? 2 squared is 4. The square root of 5 squared is just 5, because it gets rid of the square root. That's c squared, and this guy, 4 plus 5 is 9. Oh man, that comes out so nice. The square root of 9 is 3. So there he is, okay? So now that I have my figure drawn, tangent, inverse tangent of 5 over 2, square root of 5 over 2, allowed me to draw this triangle. And now from there, I want to find cosine of it, okay? So I'm going to do cosine of whatever angle that I have drawn. Cosine is adjacent over hypotenuse. So cosine of my angle theta is going to be 2/3, okay? That's what my final answer is going to look like. Adjacent over hypotenuse, 2/3. So I hope that made a little bit more sense than what example 4 did. But, you know, the thing to get away or to gather from this section is that, you know, in section 8.1, we did, you know, plus 2 pi n or plus pi n on the end of every answer that we got, because there was more than one answer. Like, it kept going to the left and to the right forever and ever and ever. But for this stuff, for inverse functions, it does not go forever and ever and ever because otherwise it wouldn't pass the vertical line test, okay, like this guy. So we have to chunk him off and only get one answer, okay? And so that's why we have to restrict him down. So make sure you have written on your unit circle these guys where he lives, and that can kind of help you do that, okay? You might have to write them off to the side over here, which is fine, but there you go, okay?